Chapter 12, Section 3. And we're going to really quickly simplify. We're going to start by just remembering how to simplify fractions. So if you have 12 over 40, you could divide each of these by 2, which would give you 6 out of 20. Divide by 2 again, which would give you 3 out of 10. So since we divided by 2 twice, the greatest common factor of those two would have been 4. If we would have initially divided by 4, it would have been quicker. And you see here that these are both even. So if you divide by 2, that's 12 out of 30. They're both even again, so divide by 2 again. That's 6 out of 15. And this has a 3 in common, so divide by 3, and you've got 2 out of 5. So the greatest common factor here is 2 times 2, which is 4 times 3 is 12. So if I would have seen that I could take a 12 out of both of those, I could have gotten to 2/5 in one step. And then just a quick recap on factoring. This is the easiest way of factoring. Two numbers that multiply to give you 6, that add to give you 5. And that'd be 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. You can check yourself by the FOIL method or double distribution. In this one, we have the difference of squares. So this is a perfect square. 2x times 2x is a perfect square, 8 times 8. That means that one parenthesis is 2x plus 8. The other parenthesis is 2x minus 8. Now, in both of these, there's a 2 in common. So I should take that 2 out. So really, I've taken 2 2's out. So I should write this as 4x plus 4x minus 4. That's my most, that's my most simplified factoring, because these 2 2's, 2 times 2 is 4, and then x plus 4, x minus 4. All right, so this next one, I'm going to look at a box. So I'm thinking of what two numbers multiply to give 2x squared times 1x squared, which is 2x squared, and add to give 3x. So that's 2x and 1x. Now, when I draw my box, I am putting in 2x squared, 1, and then for 3x, I'm putting in a 2x and a 1x. And it doesn't matter where these things are in the box, as long as they're in opposite corners. And then I need to figure out my external side length. So this would have to be 2x, which means this would have to be 1. This would have to be x. This would have to be 1. And that all works out. So my factored form is 2x plus 1 and x plus 1. And then my last one, this is perfect squares. This is 3x, and this is 10. And is this 2 times 3x times 10? Yep. So 3x plus 10 squared is my answer. All right, so why we did all that is because we're going to start to simplify these rational expressions. But first, just a quick recap on excluded values. In this one, t cannot equal 5 negative, because if it did, the denominator would be 0, and that wouldn't work. I need to factor this before I figure out exclusions. So my exclusions from this is that b cannot equal 0, because if it did, the denominator would equal 0. And my exclusion from this is that b cannot equal negative 5, because if it did, my denominator would be 0. And over here, again, I factor k plus 4, k plus 3. So k cannot equal negative 4, and k cannot equal negative 3. If my denominator is 0, I get error. When denominators are zeros, you have those asymptotes, which the graph gets closer and closer to, but never touches. So we need to factor first. Then we need to state our exclusions, and then we need to reduce. So if you look at the first equation, nothing's factorable. So my exclusion is that m cannot equal 0. If it does, it's an error. So now I have a 5 on top and a 15 on the bottom. I can simplify that to 1/3. And I have 2 m's on top and 1 m on the bottom, so I can get rid of one of my m's. So my simplified form is m over 3. So that's my simplified form and my excluded value. All right, and the next one, the bottom, this does not factor. So I need to figure out when p squared plus 2 is equal to 0, because when it's equal to 0, it will not work. So this is when will p squared equal -2, and that will never happen because a squared number won't equal a negative. So there are no exclusions. Now we're going to factor, and if I look at the numerator here, my greatest common factor is 6p, and that leaves me with a p squared plus 2, and these cancel, so my simplified version is 6p. All right, and the last one, my excluded value is n cannot equal 2. Now, when you have things grouped with pluses and minuses, this is grouped together. Did you see how I canceled this entire p squared plus 2 with this entire p squared plus 2? I can't just pick and choose what I cancel unless it's like the first one where there's no plus or minuses. If there's a plus or a minus, you are linking the entire term with parentheses, and then you can only cancel the entire term. So when I come back to this last problem, I can't just go and cancel anything here because the only thing that'll cancel is an n minus 2. I've got the 3, and I've got the n, and I've got the n minus 2, which can only cancel with another n minus 2. So this is simplified. All right, first step, factor. Second step, exclusions. Third step, reduce. I'm reducing my entire r plus 2 with this entire r plus 2. That's the only thing that cancels. In the numerator, I'm left with a 1. I can't put a 0 up there because 0 changes everything. It makes everything 0. So my simplified final answer is 1 over r plus 5. The next one, first step, factor. The numerator is the difference of squares. That's b plus 5, b minus 5. In the bottom, I have b plus 5, b plus 5. All right, now I'm going to state my excluded value. And only the denominator is excluded because the numerator can be 0. And then I'm canceling this whole entire b plus 5. So I'm left with b minus 5 over b plus 5. I cannot cancel anything more because a b minus 5 only cancels with a b minus 5, and a b plus 5 only cancels with a b plus 5. You can't just go ripping those b's off from the minus. They are linked together. It's a binomial that only cancels with another binomial of the exact same thing. Last 3 problems. First step, factor. Now, I know that I want to get an x minus 4. I'm going to rewrite this as negative x squared plus 16. Then I'm going to take a negative 1 out to get x squared minus 16. And then I'm going to factor that. That's the difference of squares. So my excluded values are that x cannot equal negative 4 and x cannot equal positive 4. Now I can cancel this x minus 4 because it's the same. If you have something like x minus 4 over 4 minus x, that cancels to give you negative 1. And the reason is because in the denominator, if I take a negative 1 out, I would get negative 4 plus x. And then, see how those cancel? Those are the same thing. So when you have everything's the opposite, it is cancelable. It worked out just fine because I took the negative 1 out. So I cancel my x minus 4, and I'm left over with 3 over negative 1 times x plus 4. If you want to distribute that negative 1, you can. If you want to put the negative with the 3 and make this negative 3 over x plus 4, that's fine. They all mean the same thing. Okay, this next one I see again as problems. The denominator, there's a greatest common factor of 2. When you're factoring, the first thing to look for is a greatest common factor. And then we have x minus 3, x plus 1. Now, I need to get up here either an x minus 3 or an x plus 1 to cancel. There's no way I'm going to get it with it reversed. So I'm going to rewrite this as negative 2x plus 6. Then I'm going to take a negative 2 out, and I'm left over with x minus 3. See how I've taken the negative out? So exclusions are from the denominator. X cannot equal 3, and x cannot equal negative 1. And then I'm going to cancel my x minus 3 with my x minus 3. So goodbye. My entire numerator, I have a negative 2. In my denominator, I have a 2 times an x plus 1. Now, do you see how the 2 is out front? I can cancel that 2. I can make those 1s because there's no plus or minus next to that 2. So my simplified version, I need to simplify it, is negative 1 over x plus 1. Last but not least, factor the top. The top was easier to factor. Well, the bottom's actually easier because it's the difference of squares. But if you're confused, this is probably going to cancel with something. So odds are, in the denominator, I'm going to have an x minus 11. And I do. This is the difference of squares. I have an x minus 11 times an x plus 11. Okay, excluded values. X cannot equal positive 11 because of this. And because of this, x cannot equal negative 11 because the denominator cannot be 0. Now, my x minus 11's cancel. I'm left with a 3 on top and an x plus 11 on the denominator. Oh. I really enjoy factoring and canceling and simplifying. Isn't that great fun? It's like cleaning things up. All right, well, I hope you enjoyed your time. Have a good night.